What is our best proof that part of the core of the Earth is liquid? Our best proof is by studying earthquake waves. The best proof we have that there is a liquid outer core is by studying earthquake waves. So let me tell you a little bit about earthquake waves. When an earthquake happens, it sends out two kinds of energy, two kinds of waves. One is known as the P wave, stands for primary wave, okay? Why? Because these are the first waves that come and hit you, okay? Let's say right now there was an earthquake up in Big Bear. The first wave that would reach us would be the primary wave. Look at how fast the primary wave travels, 6 to 13 kilometers per second. The other thing that is interesting about the P wave is that it is a longitudinal wave. Longitudinal, that means it sends you shaking sideways, back and forth, okay? Have you ever noticed that? When an earthquake happens, you are sent shaking this way. But then what's going to happen a split second later or a couple seconds later, then the transverse wave is going to come. It's going to shake you up and down, you see? So there's a couple interesting things about the P wave. It's the first wave that hits you. It's back and forth. And it travels through what? Solid and liquid. It can travel through both. So if you're in the middle of the ocean and an earthquake happens, are you going to get the P wave? Yeah, it can travel through solid and liquid. Yeah, you're going to receive the P wave. Plus, you're going to receive the ocean wave that comes to you, you know. How about S wave? Okay, S wave, well, let's see what the properties are. S waves are secondary waves. Do they travel slower or faster? 3 to 7, 6 to 13, slower. They travel slower, right? That's the second wave that comes and hits you. It's the more dangerous wave because it's transverse. Transverse means up and down. You see, buildings can take more sideways motion easily, but up and down, it's harder for the engineers to design for that, you know. That one is really bad, up and down motion, you know. So S wave is secondary, up and down, but the other thing interesting about them, they only travel through solid. Okay, how are you going to remember that for test purposes? There's an easy way to remember it. Hint? What letter is that? What's the letter? S. S, secondary. S, solid. So if I ask you which of the waves only travel through solids? Primary or secondary? Okay, you see it's easy to remember. Okay, so here's what has happened when we have studied earthquake waves. When an earthquake has happened on one part of the Earth, it has been noticed that there are no recorded S waves on the opposite side of the Earth. When an earthquake happens on one part, there are no recorded secondary waves on the other. So let's see what this means. Okay? You see here? Here is an earthquake that's taking place, and then it's sending out S wave. S wave is up and down, you see? Up, down, up, down, up, down. And it's also sending longitudinal wave. That's the P wave. This one is the P wave. So if you are here, you are receiving both waves, secondary and primary. If you are here, you are also receiving both waves. If you are here in a ship, you are also receiving, you see the secondary here? And then you are receiving the primary, okay? Now, if you are over here, what's happening? The up and down secondary wave is coming and by the time it gets to the liquid core, dies. It dies. So if you're over here, which wave do you receive only? The P wave, okay? And that's how we know that there is a part of the earth that's only liquid, okay? Same here, same idea. Earthquake happens here. If you're over here, you get P and S waves. If you're over here, beginning here, from all the way from here, all the way until you get to this green zone, you see from here to here, you will not receive the secondary wave. Over here, P and S, 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 P and S. Over here, you cannot receive the secondary wave. From that measurement, we can actually calculate how big the liquid core is. See, we measure this distance, and then we can do a calculation, you see. So not only do we know that we have a liquid core, we know how big it is. So you see, that's how earthquake waves help us to find out about information about the interior of a planet. Okay, we land on that planet like the moon or maybe Mercury, Venus. We can do analysis of earthquakes, and we can find out information about the interior of that planet, you see.